Welcome back. Last time we had a challenge, which was to find the minimum of a list. So let's see how we did. I've written up some very simple code here that probably looks somewhat like yours. So up front here, we have some list. This is going to be our input. All right, we've got 0, 1, -13, 2, -18, so on and so forth. And now we have one of those basic data types, the variable, right? That's the minimum right here. And this is interesting. I've set it equal to some list 0. Now, why would I do that? So when I indicate 0 in these brackets like this indicates to me that it is the very first element of the list. So in this case, element 0 is equal to this 0 here. And if I was to update this, the minimum is equal to the list sum list 1, this would actually equal 1. And if I was to go one more over, this would now equal -13 here. Right, so this is interesting. I'm setting the minimum to equal the very first element in this list. And then the next thing we're going to do is we're going to utilize this for loop. So for number in some list, which is this list I've created, I'm going to iterate through it. And now we're going to upgrade our programming just a little bit here. You'll notice I've used a new term here. If num less than the minimum, I've now injected some logic here. Right? So if the number is less than the minimum, right, we're going to go ahead and update the minimum to be equal to that number. Okay, so two key things here, right? I've added if, right? This is logic, and I've added an operator, less than. Okay, so if the number's less than the number, we'll go ahead and update this thing. And we're going to go ahead and print this out. Now, you'll see I ran some code a little bit earlier, so it says -999 right now, but you and I both know that that is no longer correct based on the list as it is. So let's go ahead and run this thing. And our output is -18. Which is exactly what we would expect if you and I were to take a look at this list here. Right? We see -18 right here is in fact the smallest number. Now this is all nice, but when we're doing coding, right, we need to upgrade this a little bit further. Right? This isn't terribly reusable code. So something that we could do to update this or upgrade this is to package this code into a function. Right, so that we can use it later. Okay, so I'm going to go ahead and pause the video now. That's going to be the next challenge, is stuffing this code into a Python function. I urge you to look up the documentation around that. Go ahead and pause the movie now. So the first thing we need to do here is define our function. We see this here with the keyword def. And I'm going to name this function minimum, and it's going to take an input called some list. Okay, any list. I can pass any list into this thing, and then it's going to run it through this program, right, that we've written, or this function, as we can call it, that we've written. So very similar to the logic that we showed earlier, right? We have current minimum is equal to some list starting at index 0, right? Because I want to look through the whole list. Same logic we used before for number in that list, or some list as we've defined it here. If the number is less than the current minimum, we'll update that variable, current minimum, to equal number, and then I'm going to do something called return. Right? I'm passing the result of this function. This could be used downstream for another function. It could be used for some input somewhere else, but nonetheless, I've got my input, some list, and I am generating an output, current minimum. Okay, so we'll see here I again have updated this list for input of function 1. And now we see -42, which is exactly what we would expect. Okay, exactly -42. Now, talking about reusability here again. So I'm just going to go ahead and copy this print statement and then update the input to be our input number 2 here. Now let's see what happens when we run this. Interestingly enough, there's no negatives in this particular list. but it did in fact find that the smallest number is in fact 4. Right, so there's two different ways to test out our function, one including a negative number and one including no negative numbers. This is important as well, right, for testing our functions, coming up with different inputs, right, to see if there's any edge cases we may have missed. And in this case, it seems we have a pretty well-rounded, well-functioning minimum function here. Okay, so it's now reusable. I can use it later if I want it. This is excellent. Okay, the next challenge is now that you have the appropriate tools. If you were a little lost a little earlier, that's okay. Hopefully now you're up to date and ready to go. You have this function here to find the minimum. Now I want you to write a function to find the largest number in an input list, right? So we just did the smallest, now we're going to do the largest number. Okay, so that's the challenge. And the other thing I want to share here is that minimum function is something that's already built in to Python, as is the maximum function. You don't have to do this coding again. And we have all kinds of Python built-in functions. Okay, so this is just a taste of what is in fact available to you. We have absolute value, bin, booleans, all sorts of things available to us here. So we're going to go ahead and pause the video again here, and we'll let you have a crack at creating your very own maximum function.